Good day, everyone. My name is Adam Small, a student at Grand Canyon University, currently majored in cybersecurity. And this presentation is on my CYB 610 Penetration Testing and Risk Management course. Today, I'll be demonstrating privilege escalation on my Capcheck One feature machine, showing how I was able to gain root access and successfully add a user account with my last name, Sumo, with full root privileges. Following this, I would also provide an overview of 8 critical attack families for executive training. Let's begin by reviewing the assignment objectives. So the assignment has two main components. First, I will exploit Capcheck 1 to gain root access and add a user with full root privileges. Second, I will present mitigation strategies that don't require system upgrades, focusing on network segmentation and compensating controls. Finally, I will define and categorize 8 attack families for C-suite executives to understand the modern threat landscape. Now, let's move into the lab environment. So first thing I did was to run the following command nmap-p-a, a service version detection scan against my Capcheck One target at the IP address of 192.168.56.102, and the results identify multiple services including SSH on port 22, HTTP on port 80, and NetBIOS, SSN, Samba on port 139. But the focus of this exploitation is the Open Samba service, which is on port 139. So after identifying the service, I launched MetaExplore framework to precisely identify the Samba version running on the target. The version detection is critical because different Samba versions have different vulnerabilities. So the MetaExplore console, as you can see on the right of the terminal, loaded successfully, and it shows that I'm ready to use the Samba version scanner model. So after launching MetaExplore framework, I used the auxiliary scanner model specifically designed to identify SMB versions. I entered the following command: use auxiliary /scanner SMB SMB underscore versions to load the scanner model. Next, I configure the model by setting the iHost parameter to my target IP address. In MetaExplore, iHost stands for remote host, which kind of identifies the target machine we are scanning. Once it was configured, I executed the scan by typing run. The scanner successfully identified the target as running Unix Samba version 2.2.1a. Now, this is a critical finding because Samba 2.2.18 is known to contain severe vulnerabilities that allow remote code execution without an authentication. So this version information will kind of guide my exploit selection on the next phase. So as you can see from the 3 screenshots, the first one I searched on Google for Samba 2.2.1a and I found several results pointing to known vulnerabilities. Then I click on the exploit DB entry, which shows this is an exploit number 10 with the CVE of 2003-0201, which is also a verified remote code execution vulnerability. Then finally, I click the view raw to display the complete exploit source code that I was able to copy and paste into my Kali terminal, which I will also show in the next slide. So as you can see on this next slide, I copied the exploit code from the exploit DB and used the VI editor to create the file 10.c. So after typing VI 10.c, I press the I for insert mode and pasted the code using Control Shift plus V. As you can see from the screenshots, the code was successfully pasted and I then saved and exited with .wq command. So this next slide shows after I saved the exploit code, I compiled it using the GCC compiler with the command gcc 10.c-o10. This pretty much compiles the C source code file 10.c and it also creates an executable named 10. So as you can see from the screenshot, the compilation shows it completed successfully without error and the executable is now ready to run against the target. So as you can see this next screenshot, after compiling, I ran -10 on the left of my terminal to view options. Then I also executed -10-B with O and my target IP on the right terminal. Now -B and O is for Linux platform. So as you can see, the exploit successfully ran with a brute force mode, and it shows walked message, which pretty much confirmed that the system was compromised, and it also showed that I gained root shell access. So as per the assignment instructions, I created a username using my last name, which is SUMO. Since I had root access, initially, as you can see from the screenshot, the user add command wasn't found in the path, so I used the full path, which is /usr/sbin/USERADD, and then I set the password with the password command. It is very important to know that I had to blur the password for security reasons, since this is going to be uploaded on YouTube. But as you can see, it shows it was created successfully. Also, the right screenshot shows my Captric login screen with my username Sumo, confirming that I successfully logged in with the password I created. But note that I wasn't done, because I had to grant full root access to the user I created, which is my last name Sumo. So in order to do that, I ran the following command: user mode -u, and then o -g o, and then space dash with 0, and then Sumo. Now this sets the UID and GID to 0 or root. The ID small command confirms the UID equals 0, which is root, and the GID equals 0, which is root. The right screenshot, as you can see, shows successful Captric login as Sumo, which proved that the account has complete root privileges as it was required by the assignment. So with the exploitation process completed and the root access on Captric One machine successfully established, we can now proceed to the mitigation, which we're going to focus on this next slide. So in reality, in most real world scenarios, especially in the ones that run legacy applications, any chance of upgrading or replacing a host that is vulnerable is not an option immediately. This is where the compensating controls are to be used. First, the vulnerable host are to be put on a different VLAN to protect them in case of an attack to the system, such that all the other networks would be safe. We then block unwanted SMB exposure and save traffic to trusted management IPs. Enforcement of least privilege and multi-factor authentication minimizes the chances of credential misuse by administrators. Any administrative sessions are supposed to pass through a jump host or VPN to manage and track activity. Lastly, detection. The use of tools such as EDR, HIDS, and SIM alerts will enable us to track uh, suspicious activity early in its occurrence. Backups, integrity checks, and periodic penetration testing ensure long-term resilience. On this next slide, we will focus on buffer overflow and privilege escalations. So buffer overflow and privilege escalation emphasize how core vulnerabilities can result in complete system compromise. Buffer overflow occurs when a program exceeds memory buffer limits, allowing attackers to inject code and gain unauthorized control. This vulnerability continues to affect legacy C and C++ applications. Privilege escalation happens after initial compromise, where attackers exploit system loopholes to elevate from normal user to administrator or root. As you can see on the slide, sources from Fortinet and Farley detail these attacks. Key defenses include secure coding, access control, and monitoring of privileged activity. Now let's talk about rockets and Trojans, which are both deceptive, but they also operate very differently. A rocket walks deep in the system at the kernel or firmware level. It hides files, processes, and network activity, which tend to make it extremely difficult to detect and remove. When a rocket is present, the attacker has stealthy, persistent privileged access. Trojan, on the other hand, is a malicious software that disguises itself as something legitimate. Users are tricked into installing it, usually through phishing or fake software downloads. Once it's executed, the Trojan can open backdoors or steal data. As you can see on this slide, sources from Zenoma and Baker detail these attack types. To defend against these threats, organizations must focus on user awareness training, strong application controls, and continuous endpoint monitoring. Early detection is also a key to stopping long-term compromise. Now, let's talk about backdoors and viruses on this next slide, which are both ways attackers maintain persistence, but they work differently. So, a backdoor is a hidden access path that bypasses normal authentication. Attackers often install a backdoor after gaining access so they can return later without going through login controls. This makes backdoor a long-term and high-impact threat if they aren't detected. A virus, on the other hand, is a self-replicating code that attaches to legitimate files or programs. It spreads when someone opens an infected file or plugs in an infected USB. Once active, it can corrupt data, steal information, or disrupt normal operations. To defend against both, we limit administrative access, ensure software and updates come from trusted sources, and use regular system scans and file integrity monitoring to detect unauthorized changes early. Return-oriented programming, or ROP, is an advanced exploitation technique where attackers don't need to inject new code. Instead, they reuse small existing pieces of code already in the memory called gadgets. By chaining these together, they can perform malicious actions while bypassing defenses like data execution prevention and address space layout randomization. ROP is typically used in high level or targeted attacks because it requires detailed knowledge of the system. Social engineering is different because it focuses on people and not systems. These attacks use psychological manipulation to trick users into revealing credentials or taking unsafe actions. An example include or some examples include phishing emails, fake login pages, pretext phone calls, baiting, and even tailgating. Together, these show that technical defenses and user awareness training are equally important. Even a strong system can be compromised if the human element is not protected. In conclusion, the following are the five strategic actions we as leadership body must embrace to make us more resilient in terms of security. The first one is to invest in staff education and email security, as the majority of intrusions begin with social engineering or phishing. Second is to decouple legacy systems and give less access. The third is to establish a layer defense technology, explain a policy, and develop an organization culture. Fourth, we should put an early establishment of incident responses and attack containment measures. And then lastly, periodically improve the security process with evaluation and updated awareness programs. The measures will drastically cut down the risks that the organization faces and business continuity. Finally, this last slide is my references. That is where I got some of the information I've been talking about throughout this presentation. Thanks for your time and stay blessed.